All right, number 3 might be the hardest question on this entire review. In a recent survey of 25 voters, there are 16 in favor of a new city regulation and 9 oppose it. What is the probability that in a random sample of 6 respondents from this survey, exactly 2 favor the proposed regulation and 4 oppose it? Well, the first thing we got to do is figure out what's the total number of ways we're choosing 6 people out of our 25. So how many total ways to choose 6 out of 5 people? Or 6 out of 25 people, my apologies. Now, in this case, the order doesn't matter. It doesn't matter if they pick Billy first and then Bobby or the other way around. So this is a combination. So we have 25 as our group size. We're doing a combination where we're choosing 6 people. Now, you can punch this into a calculator. It'll give you the answer nice and quickly, but in case you forget how to punch it into the calculator, remember you put the n on top, and in this case it's 25. So 25 factorial over r factorial, in this case r is 6, times n minus r, or 25 minus 6 factorial. Cleaning this up ever so slightly, we get 25 factorial over 6 factorial times 19 factorial. Now, I could go through and write this out the long way, but if I pay close attention, this 25 factorial up here is 25 times 24 times 23 times etc., etc., etc. Now, this 19 down here is 19, 18, 17, etc., etc., etc. This 25 factorial up top includes everything that's in the 19 factorial. So we can cut out everything that was in the 19 factorial from the top. So we'll do 25 times 24 times 23 times 22 times 21 times 20 times, well, that's it. We decided to cut off everything that was in the 19 factorial. That whole piece canceled out. So on bottom, we're left with 6 factorial, which is 6 times 5 times 4 times 3 times 2 times, well, the unnecessary one, but I'll leave it there anyways. Now, if I start going through, I can reduce some of this by hand. Of course, I could punch this into a calculator as well using the factorial buttons. But again, just in case you forget how to use the calculator, well, we can do this by hand. So I'm going to reduce what I can. This 5 and this 25 can reduce down to 5 on top, and this, well, we just get a 1 down here. Now, we also have a couple others. If I take 6 times 4 down here, which is 24, this can cancel off with that 24 up top. So that's going to be 24 divided by 24, giving us, again, 1. Now, I could also take this 3 here and the 21. 21 divided by 3 gives us 7, so again, we get another 1 down there. And the 2, I should switch colors, the 2 and the 22 we could divide and reduce it to 11. And again, 1 on bottom. Now, going through this, on our denominator, we just have 1 times 1 times 1 times 1 times 1. Doesn't matter how many 1s I have, it's all multiplied, still giving us 1. I'm not even going to bother writing that part. Now, on top, we have 5 times 23 times 11 times 7 times 20. When we plug that into our calculator, we get 5 times 23 times 11 times 7 times 20, giving us a total of 177,100. Sorry, my pen skipped there for a second. So that's the total number of ways. I should spell that correctly. Now that doesn't give us our final question, or our final answer. We're looking for a situation in which exactly 2 are in favor. 2 out of how many? Well, 2 out of the 16. And we're also looking for getting 4 out of the 9 that are opposed to it. The best way to do that is to, again, set up combinations. We have a total of 16 people in favor, and we're trying to get 2 of them. We also have a total of 9 people opposed to it, and we're trying to get 4 of them. Now, again, the order doesn't matter. It doesn't matter if I pick me, then Mr. Osbeck, and then Mr. Fay, or switch the order up. It doesn't matter as long as we're all chosen. Now, for time's sake, I'm going to plug this into a calculator. you would follow the same process like you did up here, canceling stuff out, plugging stuff in, reducing and reducing, reducing. However, for time's sake, I'll plug this into a calculator. So when I do 16C2, we end up with, sorry, you can't see what I'm doing on the calculator, but I can refresh you on that if you need it. So 16C2, that gives us a total of 120. So there are 120, let me switch colors. There are 120 different ways that we can choose 2 people out of 16 people. We're going to multiply that by 9C4. So 9 people, you're using a combination where we're choosing 4 of them. And that's 126. When I multiply those two numbers, I end up with 15,120. So these are our favorable outcomes. So that's our favorable outcomes, the number of outcomes we could get that would make this statement true. So to figure out the probability that this happens, you'll end up doing the number of favorable outcomes, 15,120, divided by your total number of outcomes, which is 177,100. Plug that into a calculator. Again, I'm doing this live, that's why I'm taking a few seconds. Reduces down to express your answer as a decimal. We get 0.085. So about 8